Hi guys, here is a presentation of glsl.js. glsl.js is a tiny library I've made last week. So we're going to start making a simple example with it. So let's start by creating some HTML, a canvas. So glsl.js is a WebGL library. So we're going to use a canvas width and 8. And because of its WebGL library, we're going to implement our rendering part in a fragment, and the logic part will be in JavaScript. This is why we are going to split our code between the fragment and the JavaScript. So first, in JavaScript, you need to give to glsl the canvas you want to work on, and you need to give the fragment code, which is basically the text, the inner HTML of the script you have on top. Then you need to give all variables you want to inject to your fragment. For now, we don't have any variables. So let's see if it's working. So as you can see, it means some, of course, there is no GLSL code. So we are going to start by adding the resolution uniform variable, and we continue like this. So now you need the precision, which actually defines the float precision you want in your GLSL. And then you need to implement the main function. Okay, fine, now it compiles. Let's continue. So first of all, let's introduce the Frag Color. Frag Color is actually the color you want to set to a given pixel. Let's put every pixel at RGBA 10.80.5, and we have this color. So actually the main is some kind of a loop which is called for every pixel. Actually it's the concepts. It's not exactly like this because you can actually define different resolutions, but it's the main concept. Okay, as you can see, Frag Color is quite flexible. You can just set some fields, or you can just set RGBA, or just set it like this. And it's a vec4 because it's 4 components RGBA, vector 4. And now let's introduce the Frag Color, which is actually the pixel position of the current main call. And here is a way to get the x coordinate from 0 to 1. And if you give this to the R component of the color, you have a cool effect of gradient. And let's continue like this by putting also the Y in the G, in the green component. And you have a cool Hello World example. But you can also just use the position as a vector of 2 components by dividing the frag chord by the resolution. And it's the same. So that's it for now. What can we do now? Let's start using variables. So going back to the JavaScript code, we will inject the time. We want in the GLSL to access the time. the current the time starting at 0 and in milliseconds. So with glsl you have to implement an update function, and it gives you the time in parameters, so it's quite fine. Behind there is of course all this request animation frame stuff, etc. So it's cool. And now let's use the time in the glsl, and let's put it in the RGB, the blue component. So we need to rotate the color. So let's use cos for now. And as you can see, it's very fast. So we need to divide by something or multiply by something small. Okay. So now it's fine. But as you can see, because of cosinus, it's -1 to 1. So we need to change this. And for that, you have a cool function called smooth step, and you give two values, the min and the max, and then the value you want to map. And what it do, smooth step, you can see in the spec actually how it's defined. Let's go to the spec. Okay, just adjusting some values. Okay, fine. Let's go to the spec and let's search for smooth step. And smooth step is defined like this. So yeah, if you want to read more about all function you have, or everything, go to the spec. It's really well written. Everything is here. So actually, smooth step just return a value between 0 and 1, which is the value you give in third parameters is map in the min and max, and with not a linear way to do this, but more quadratic way, so it's quite cool. Okay, in circle, let's define a way to draw a circle. In circle is a Boolean function. It's a method you can call to know if a given point P is in a circle, so is in the disk of center and radius. So it's a predicate. This is why it returns a bool. It's, as you can see, it's really close to C syntax. It's quite cool. You should not be so lost by this actually. So instead of doing the classic way of doing circles, x square, y square, less than radius square, just use this. We can just use the distance function, predefined function, which checks the distance between two vectors, and just less than radius. Oh, it doesn't work. Why is that? Because of course we need to use it, but we will also need to define the color outside of the circle. So if I do this, it's not enough. If I reload, yes. So of course we need to implement the else. And let's put black. Oh, cool, fine, we have a circle. But as you can see, it's not a circle, it's more an oval. And why is that? Because we divide the resolution by the resolution XY, and we don't have a square canvas. So to fix that, we have different ways to do it. We can divide by resolution, try something with working with better, instead of using a percentage way. You can do anything, but let's do a ratio. Let's compute the distance with the ratio. So doing like this. Wait, I think I miss some. I try something here. It was wrong. And of course the ratio is on the vec. You need to work on the vec2. Okay. And yeah, just the type. If it's not a float. I actually code live, so this is why I try some codes. And actually it's a way of doing GLSL. I think it's a good way to discover things. You can just go to glsl.js and try stuff. It's quite cool actually. Okay, so now if you use a proper ratio, you have the circle working. Cool. So now let's continue and define a uniform center, a center variable. So uniforms are all variables which are given by the JavaScript part. You always need to prefix uniform. You have also other types like const and other things. Okay. So now we just give the center and the radius to the GLSL and let's binding them here. Oh, fine. And now let's change the position of the circle depending on the time. So we have different ways to do it with GLSL. You can use the set function, or you can also call the sync function if you change the variable and you can just sync them, or you can override the variable with doing set approach. Okay, let's just simply do set. And here it's not working yet because I need to give the time, of course, it's not constant. Okay, let's do it. Nice. Oh, here we go. Sounds like James Bond, no? And now let's define a ball constructor. Let's get into a more object-oriented way of doing things, like defining a ball class with two fields, center and radius, and we will see how to inject it to GLSL. Let's also define a vec2 constructor just for convenience for the JavaScript part, and just x and y component. And let's define our first ball. No, first of all, let's define the update function. Update will be called by my main update. So update means update the position of the ball, and it takes a time. It takes the time so you can change the variable like we have done here. So here is our first ball, finally. No, not yet. Yeah, let's just do it here. There's different ways to implement this actually, of course. So you can actually directly give it to the variable parameter, or you can store it somewhere in the global scope. Your choice. And we don't need anymore these variables. And let's just call the update of the ball, giving the time, and you can synchronize the ball. Why synchronizing? Because you need to say to the GLSL library that this has changed, because you don't want to synchronize every variables all the time. It's more efficient like this, especially if you have images or stuff like this. So in the GLSL part, we can define a struct which contains the center and the radius field, like we've done for the JavaScript part. It's quite easy actually, and you can also then define the uniform ball name ball, and using it like before. Cool. Okay, it's not working yet because of course it's not this dot ball, it's this dot variables dot ball. And fine, it's working. So now we have a real object-oriented approach of doing this with GLSL, which is really cool. Because if we only have variables, it's going to be not really scalable. But now we can just have different objects for your logic and just inject them, which is really cool. Really. Okay, velocity. Let's add a velocity to this ball because right now we just have a absolute way of changing the ball position, but we want a more basic physics for this ball. So we will change the x and the y of the center of this ball by multiplying the velocity and adding the velocity and multiplying by the time. Actually, it's not the time. I made a mistake too here. It's not the time, it's a delta time because it's only the time which has passed since the last update. So I will fix this later. Okay, let's give an initial velocity, and it's really fast. Yeah. Okay, cool. We have a velocity. It's fine. Working. Even a bit small. Slower, I mean. And you can add a logic to make the ball bouncing. Wow, cool. We can make the ball bouncing, guys. And how we can do this? Just constraining the ball position and inverting the velocity when you hit the wall. It's simple, as simple as this. And you need to do it for the four edges. So let's do this. Wow, fine. We have a bouncing ball, except it's not a linear one, it's accelerating. Why is this? Because we have a time. We use the time instead of the delta time. And I just figure out here at this moment. So we can fix it. And of course, the delta time is given as a second argument of the update function. So it's cool, you don't have to handle this, it's already here, it's already in the library itself. Cool. Okay, what we can do else? Change the color a bit to have it lighter. Okay. Now, let's try to make more balls, not only one bouncing. And this is why object-oriented is really cool for this, because you can just define a balls as an array of balls variable. Cool. We can just put it here. And here we are going to push in the array every balls. So let's keep this here, and we will use random mat.random function to have different velocities, different initial positions, and different size. I'm coding really slow actually. Okay, and we loop through 0 to 10 as a start. And that's it. And now let's synchronize the balls array to the GLSL. And on the GLSL part, we are going to change this variable, uniform variable, to a balls array. And doing this, you can, like in C, you can define an array of length 10. Let's start for 10. But then it's not a variable array. So this is why we will need a balls length variable to give, and we will just synchronize it with the length of the JavaScript array. Every update loop, we are going to update this variable. So later we could remove or add new balls. And let's update every balls of the array like this, with for each balls do a ball.update. Okay. So what are we going to do now? We are going to try to iterate through all balls, and if the position is in this ball, we set the color like before. So first of all, the normal way to do this will be to iterate from I equals 0 to balls length. But with GLSL, we can't do this. I think it's a WebGL limitation. It's not an OpenGL limitation, it's a WebGL. You can see on some mailing lists people saying about it, people complaining about it, but still, okay. So we're going to use a workaround to iterate through a variable array size. The issue is we can't put variables in the for loop. Don't know why, but okay, this is a workaround. So if we are greater than the balls length, just break the loop. It's quite ugly, but it works. And yeah, sorry, I missed something. It's not a float, it's more an int. So we are in the right types. Okay, so now it should work, and let's just use InCircle for all balls. But we will more need in ball function, predicate function. So let's define it. It's just a shortcut, actually. Just an alias of InCircle. Let's return InCircle. And I give all required parameters. Okay. So now, if we are in a ball, if the position to draw is in the ball, we just draw the color. Otherwise, if there is no ball at all, we just set the background color, and we can just do it like this, starting with the background color and re-overriding it. And you can see it's really cool. We have made a balls bouncing in 10 minutes, 20 minutes. And that's it for now. I hope you enjoy it, and I hope you will use GLSL for your next projects. See you!